Lovely. Hi everyone. So, do I have visuals? Lovely. Hello. This is probably the best room I've got to. I think this is brilliant. Like, thank you for having me. So I'm Nikos Tsouknidas, and this is my colleague Joe Hart. We're both engineers and developer advocates for the BBC ux&d team. And today we're going to talk to you about silos and in big, brilliant corporations, and give you some insight on how you as software engineers can do something to fight against them. I'm going to talk about the abstract machine stuff, and then Joe is going to give you an example using fonts. So what is a silo, apart from that, the literal thing? So practically speaking, it's lack of communication, and a private repo, I guess. Another thing is different priorities. Different priorities make silos. Different product owners, different managers. One characteristic of silos is that they're endemic of your company's culture, structure, and of human meaningful relationships. But silos actually occur naturally in big organizations, and they do serve a purpose. They provide ownership and control for teams and their managers, and they're needed for accountability, ownership, and independence. So from a company's point of view, silos are actually important. The problem is that sometimes people in these silos have to actually work together. And not all companies start with silos, and it depends how big your company is. But how big is a big company? So for us, our team in ux&d is like 120 people, 120 designers. We have a little bit more people in there. And our greater division, digital and design and engineering, is 1,300 people. And the public part of the BBC is around 20,000 people. Actually, 20,916 says Wikipedia. I googled that. Should ask HR actually for the right one. Facebook's around the same number. Facebook's around the same numbers as BBC. Not just Facebook. Anyway, another big company is Google. Google is 73,992 people, and I did Google that. And another big company, you might have heard of them, is IBM. How big do you think IBM is?
400,000?
So IBM is 380,000 people. So, like, you probably don't know like stuff that IBM does. They're everywhere. Mostly in every ATM that you use, there's something that IBM is doing. So, depending on how big your company is, you might think this is not about me. We don't have silos. We're a small company. It's huge. Have you heard, though, about something called Dunbar's number? Wait, wrong number. I'm talking about this Dunbar. So this is not from the game, the House of Cards. This is the actual number. So he's a British anthropologist, an evolutionary psychologist, and a specialist in primate behavior. Right, let me read that out loud. So, Dunbar's number is a suggested cognitive limit to the number of people with whom one can maintain stable social relationships. And the number that we're talking about is around 150. And there is criticism about this. But most people put it up to maybe a maximum of 300 people at best. Now, there is a grain of salt in every anthropological study. But what we're learning here is that there is an actual hard limit to the number of human meaningful relationships. And so how is 150 for the company that you work in? Is that sounds a little bit closer to most companies, I guess. The thing is that it's not actually 150, because that is all of your meaningful relationships. So for your work, let's be generous and say 50 people. So maybe we have a solution. So you just break down your company to teams of 50 people or less. They have nothing to do with each other, they're completely independent, isolated, they don't know each other, and they don't have to coordinate. And that's it. That's what the problem. But usually things don't work that way. And there are cases where we have to work together. Now, for engineers, there is a way to battle silos, and that's reuse. For managers and CTOs and all these people, it's probably something else. They go to a retreat and there's one of these trust games where they fall into each other's backs and whatever. But for us engineers, this is the way to battle reuse. The thing is that a lot of people have a warped idea of what is reuse in engineering in general, software engineering in particular. So let's talk about that. So do you think reuse is a technical solution? Let's see what we have for that. We have containers now. I'm going from the back end, I guess. NPM. We have web components. And we have CSS scoping. Now you can write code and you don't care about the cascade anymore. Like just throw your CSS there and like Webpack will figure it out. Will scope it. So you write reusable code and you're sorted, right? That's it, you're reusing. The problem is that reuse doesn't need a technical solution. For example, when you reuse means, when you're reusing software, it means you're creating dependencies between software. So it means that software A cares about software B, which means that team A cares about team B, means that person A cares about person B in a different team. And somehow we're back from technology, we're back into meaningful human relationships. And Dunbar's number is somewhere there, it's creeping that. Another thing about reuse is that it's not binary. And it sits on a spectrum. On one side of the spectrum, you have innovation, risk, new technology, freedom. And on the other side, the gray side, which you can barely see, has, you see, control, safety, strictness, rules. And the thing about this spectrum of reuse is that you actually have to be dynamic in your company when you're reusing stuff. Sometimes you have to be on one side and you have to innovate and take risks and use new technology. And sometimes you have to actually use the same stacks, the same technology, because you have to go faster. Or it's not the time to innovate. So you can't expect to be on one side or the other all the time. And you're either too safe and not creative, or too innovative and you're taking too many risks. So the BBC obviously as an organization errs on the side of more reuse, but that doesn't mean we don't go further into the colorful spectrum there. And actually lately we're moving all of our stuff into AWS, in cloud, which is giving us room for total control sometimes. Another thing about reuse is that it's hard work. Like, reuse is hard work, and that's the plain truth. You have to write documentation, you have to keep everything updated, you have to respond to pull requests. So make one thing configurable, not just for you, but for one other person in a different team, and the whole thing becomes way more complicated. And I mean, you might say that writing good documentation, making things reusable is just good engineering practices, but the truth is, if you're adding another configuration option, you're still making things even more complicated in your web components or your services. It's just hard work. There's actually a really nice, really great paper from Nate Porter Edwards of IBM, which was written in 1977, and it's on architectural requirements of an engineering system. Well, back then, he was talking about microelectronics, but computers back then were microelectronics. And in there, he's stating that, let me try to read that without breaking it down. The functional performance of any configurable or reusable element must be independent of its embedment in any particular architecture. That's difficult to say. So that is difficult. How can you make something that's independent of the architecture that it sits in? Like if you just write a little bit of JavaScript and put it on a web page, you will figure out that this is difficult to make, completely independent. Now, in the BBC, we are developing some new technologies, you might say, to help us with this. Our own Matt Clark has written a very nice video post about something that we call nanoservices. So you know what a microservice is. Nanoservices are even smaller, and they take the Unix approach, which is do one thing well. And usually microservices offer a RESTful API where you have many multiple commands, you have posts, puts, gets, and all that stuff. In a nanoservice, each command will probably be its own endpoint, its own little service. So the way you use these is they have an endpoint, and they're mostly used to template data. So what they respond with is something that we call an envelope format. And when we use this in front-end components, the nanoservice will reply all the stuff that you need to put in your HTML in the right place. There is something in front of that service that takes all of the envelopes and weaves them together. So you go from your data to an actual web page. As long as the service that weaves them together knows where it goes and dedupes the CSS and runs some acceptance tests and all that. Now, again, this is a technical solution that helps us with reuse. But, as I said, it's not really, reuse isn't just a technical solution. It's like there's a human problem in there. And also, there is a structural problem. So, along with all of this nice technology, new technology, APM, web components, we need to make organizational changes to break silos with reuse. And these are the difficult ones because we actually need to move people around, people have to change teams, and we don't like changing teams. Most engineers don't like changing the way their monitors are set up. So, you know that. And there is a law about structure in organizations called Conway's law. That's not the right Conway. I'm talking about Melvin Conway and not Kellyanne Conway. So Melvin Conway, computer scientist, computer programmer, and hacker, he said, let me read that again. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So there's a lot of organizations in there. Basically, Conway's law tells us that the structure of your teams will be reflected in your code and your products. So if you have deep vertical slices in your teams, that will show up in your product. If you have horizontal teams, This works both ways. Like if you are using code or a software, a product that feels like it's written by two different teams, it probably was. If it feels like two different products, one side the other, it was probably made by two different teams, probably siloed. So just to wrap this up, generally teams to get away from silos need cultural change, and we need cultural change that allows organizational flexibility. We know good design is easy to change, so good design in organizations and structure of organizations is easy to change. Do we have any bread makers in the audience? Yeah, you're my man! So, when you make bread, you don't follow a recipe, right? When you make bread, you follow a strategy. And the difference is that with a recipe, you just follow the steps. It's a paint by numbers game. There is no feedback loop. When you make bread, you need a strategy because you have to observe and anticipate and act accordingly. So, I don't have a recipe for opening silos, but I have a strategy, and this is reuse. And much like sourdough bread, right, Colin? It needs culture. That is it. That is actually my sourdough culture. So, apply all of that to a simple change on all BBC websites. Let's say that we wanted to make one simple change in all BBC websites, and let's say that it's as simple as adding a font. Simple enough? Well, after the break, I think my colleague Joe will tell you exactly how simple enough that was. Thank you.